Okay, our last section to cover in Precalculus, section 6.3. We're going to get just a basic introduction to polar coordinates, okay? Polar coordinates is another way of looking at points in a coordinate plane. You're used to rectangular coordinates, right? The x, y coordinate of a point in a plane. Polar coordinates is another way of thinking about it, and when you move on into calculus, you often need to start thinking about polar coordinates. It takes a while for it to totally sink in, so we like to start covering it in pre-calculus. All right, so the relationship between polar and rectangular coordinates is pretty easy to follow if you just understand this one picture right here. So let's say we have this point sitting in the xy plane. Well, that of course has the coordinates xy, right? The x coordinate is this distance out on the x-axis. The y coordinate is this distance out on the y-axis. So that has the points. That has the coordinates xy in the rectangular coordinate plane. If we think of polar coordinates, they still exist in this rectangular coordinate plane, but they have a relationship between, instead of thinking of it as a plane, we almost want to think of this xy as lying on a circle. So we know that that means trig functions are involved. So that means that r, the first coordinate in the polar coordinates, right? Instead of x and y, we use r and theta. The first coordinate is r. Well, r is just the distance from the origin to the point. So from the Pythagorean theorem, r squared would be x squared plus y squared. So we think of the relationship then as r squared is x squared plus y squared. Okay? And then theta, well, theta, there's many ways to think of theta, but most people will identify it this way as the tangent of theta. So theta is the angle from the x-axis up to this ray where we measure the distance out to the point, so up to where r is measured. This is the angle theta. The best way it's mostly described is the tangent of theta is y divided by x. Okay, so that's how you get this. So what's x in terms of theta? Well, in terms of r and theta. Well, cosine of theta is x over r, so solving for x, you get x equals r cosine theta. And sine of theta is y divided by r, so y is r sine theta. So if you know r and theta, here's how you get x and y. And if you know x and y, here's how you get r and theta. R will always be a positive number, right? Because it's not always positive. It can be negative because what happens is if you measure it from here out, we would say that's positive r. But if I wanted to make it a negative r, like let's say I had a point over here, the negative r would be in this direction. So some people will do that, and you'll see how that works in just a second. So example 1. Find the rectangular coordinates of the polar point minus 5, 5 pi over 2. So first of all, where is minus 5, 5 pi over 2? So first of all, where's 5 pi over 2? Well, if I start here, remember it's always measured from the positive x-axis, so I go all the way around once, that's 2 pi, which is 4 pi over 2. So another half a pi is up here. That's 5 pi over 2. So 5 pi over 2, the direction of 5 pi over 2 would be this way, in the positive y-axis. But because I gave my r coordinate to be minus 5, it means don't go in the direction of 5 pi over 2. It means go 5 units opposite of the direction of 5 pi over 2. So that's down here. So this is minus 5 pi over 2. Now we can easily see without doing any conversions that that means that the xy coordinates are 0 for x and minus 5 in the y direction. But if I use the formulas, x equals r cosine theta, so r we know is minus 5, so it's minus 5. Cosine of 5 pi over 2, which is the same thing as minus 5 cosine of pi over 2, which is minus 5 times 0, so 0. And y equals r sine theta, minus 5 sine of 5 pi over 2, which is minus 5, so that puts us down here. So because we have a negative r, that means it points in the direction opposite to theta. That's how you want to think of negative r's. Okay, example 2, find the polar coordinates of the rectangular point, minus 4, minus 4. So now we're down here. Here's our point minus 4 in the xy plane. So what is it in terms of r and theta? So minus 4 and minus 4, it's my x equals minus 4, my y equals minus 4. This has xy coordinates minus 4, minus 4. What is it in terms of r and theta? Well, r squared is x squared plus y squared. So that's 16 plus 16 or 32. Take the square root of that to get r. Square root of 32, that's the square root of 16 times 2, so 4 square root of 2. So if I measure it from the origin straight out to the point, that's positive 4 square root of 2. That's r. Now theta is the inverse tangent, right, of 1. Because tangent of theta is 1. So inverse tangent, that's a 45-degree reference triangle then, but I'm always measuring it from the positive x-axis. So that's pi plus pi over 4. So it's 5 pi over 4. So your r theta is 4 square root of 2 times 4 square root of 2 comma 5 pi over 4. That's your coordinates in the polar coordinate system. All right, the other thing we want you to be able to do is convert a rectangular equation like this to a polar equation. So x squared equals 8y. All right, well, how do I do that? Well, I know that x is r cosine theta. I square it. And then y is r sine theta. So r squared cosine squared theta equals 8r sine theta. Divide both sides by r, I just get r. Divide both sides by cosine squared, I get 8 times the sine of theta over cosine squared theta. So some people would like to write this without fractions. So sine theta over cosine theta is tangent of theta, and then 1 over the remaining cosine theta is secant theta. So that's the best way to write it. R equals something. We always want to write it as R equals something when we're writing a polar equation. All right, r equals 4 sine theta plus 6 cosine theta. We want to convert that to a rectangular equation. So if sine theta, so what we have is y equals r sine theta. So what is sine theta by itself? It's y divided by r. X equals r cosine theta. So what's cosine theta divided by itself? X over r. So now I have r equals 4 times y over r plus 6 times x over r. So I'm going to multiply both sides by r. I get r squared equals 4y plus x. Then I realize, okay, r squared is x squared plus y squared. Now I have this actually all in terms of rectangular coordinates at this point, but it's really nice because whenever I see an x squared and a y squared, I should understand I have a circle. Okay, so I'm going to go ahead and do my completing the square here. So when I complete the square, I'm going to subtract 6x and 4y from both sides. And I get x squared minus 6x plus y squared minus 4y equals 0. Now I'm going to complete the square. So to complete the square, I take half of negative 6, which is negative 3, and square it. I add 9. If I add 9 to this side, I also have to add 9 to this side. How do I complete the square here? I take half of negative 4, which is negative 2. I square it. Gives me 4. Add 4 to this side. I got to add 4 to this side. The reason I did that is these become perfect squares. X minus 3 quantity squared and y minus 2 quantity squared equals 13. So now I can identify that I have a circle with a radius at 3, 2, and with a center at 3, 2 and a radius of the square root of 13.